Welcome back, ladies and gentlemen.
Welcome, folks, to another episode of Eigenbros.
Mm-hmm.
Just want to say, as the title suggests, what we're talking about, we do want to say thanks to our Patreon subscribers.
Thank you, guys.
Shout out to them.
And then, of course, guys, if you want to support us, make sure you check out patreon.com. I think it's /Eigenbros. If not, just type in Patreon and Eigenbros, and you'll find us pretty easily.
Yeah.
Donate $1, and you can support the show.
Yep.
That's all we need, guys.
We get a lot more intimate and private on that one.
Yeah.
But if not, like, comment, share, subscribe. If you like what you are hearing.
Yes, and then, of course, check out the Eigenbros.com website. We got some practice problems on there, of course, still, and then also the podcast episodes. Check out Eigenbros on Instagram, Eigenbros on, what am I missing one?
Twitter.
I said Twitter. Twitter.
Twitter
yes.
and everything.
Twitter.
Besides TikTok.
Yeah, and TikTok is Eigenbros 2.
Yeah, so.
And that's it.
That's it. So let's get to it. We actually wanted to talk about certain types of people within the community. We love all our Eigen brethren and Eigen sisters, but there's a certain segment because we make UFO videos and stuff. We're fans of the science fiction. There's a certain, how would you say,
certain demographic that likes to email me theories of everything and why Einstein's wrong, and their world changing physics problems and equations and things. So I appreciate your attempts for sure.
We do appreciate, no matter how outlandish they may seem.
Right.
We do appreciate the creativity in them, and for reaching out and the engagement with us. We do appreciate that, but we do kind of want to give a roadmap on how would you say. How to do physics if you're a non-physics person, right?
Yeah. So I would say, guys, I appreciate you trying to prove Einstein wrong, but I think you're going to need a lot of education and physics to be able to even attempt to do that. So I've come up with some things, I guess, that I think would be much more better served if you actually want to be a contributor to physics in a meaningful way. Okay. So I came up with a couple things.
Right. I haven't heard these, so run them.
Yeah.
I want to hear.
Yeah.
Run them by me. Let me see.
So I guess just to preface, I was trying to think, okay, where's a good place to start? Like, so let's say you don't know anything about physics, right? And you just love the idea of becoming a physicist. You respect what physicists do. You think it's really cool just understanding new things about the universe. But you want to contribute in a meaningful way. Well, first off, I'll say that theory. So there's two branches of physics, basically. We can divide it into theory and experimental physics. So, of course, the theoreticians are the ones who come up with formulas. They're the ones who are, deriving equations from scratch, using mathematics heavily. They're like the Einsteins or the Feynmans or I guess Newton was kind of a combination, but they're the ones that are coming up with the kind of the equation for how some system works, right? That is going to be pretty hard. Then there's the experimentalists who are the ones that actually come up with the things that are testing these theories, right? Like, for instance, the Kip Thornes out there who, was responsible with the gravitational wave detectors.
Yeah.
There's who's some other good experimentalists? They're a lot harder to name.
Think of Nobel Prize winners. Those guys are probably mostly experimentalists.
Yeah, Penning, I think, was like another good one. The guy who invented the Penning trap.
Yeah.
But those are the guys that are in the lab that are actually...
I think. Yeah, the graphing guys as well.
Yeah, the graphing guys. There's a lot of experimentalists out there who are the ones that are proving these things true with actual evidence that we can see in real life.
Or just finding things, right?
Yeah.
Just like just kind of shooting from the hip.
Yeah.
Seeing what fish going fishing and see what they catch, really.
Yeah. There's a little bit less of that, but yeah, you're right. It can happen.
It's usually an educated guess.
Yeah. So those are the two major ways you can divide physics, I would say. And I was thinking that, is it better to be a theoretician or experimentalist? So, of course, most people only know of the theory part. And most people out there who, talk about physics are mostly theoreticians. me and Juan are experimentalists. Well, Juan is experimentalist.
Yeah.
I'm an ex-experimentalist. And I actually think
But
that
I think if you
experimental.
took a scientific job, you would probably be a lab
Yeah,
technician.
I would not be a theory guy.
Yeah.
So experimental physics is much more obtainable, I think, for the average person, let's say.
Yeah.
I'm not saying that anybody who's doing this stuff is average. Of course, you got to be smart to be doing physics anyway, but experimentalist stuff is very
Approachable.
It's very approachable, right? Because we all kind of have an innate sense of how to do experiments, even if it's not, something that's that you're good with. But we all kind of do experimentalists just with our everyday lives, right? Like cooking things. If you cook a meal for the first time, you have to experiment on getting the right measurements in.
Yeah.
The amount of butter and salt or whatever you need to put in there. And that's pretty much what experimental physics is kind of like.
Yeah.
So I was thinking that experimental physics is probably the route to go if you're trying to contribute meaningfully to physics.
Yeah.
Now, with that said, it is possible to do theory, but it requires a lot of time and energy in studying. So the preliminary work to be a theorist is a lot heavier. The barrier to entry for that is like a fucking giant. Like the slope is so high that it's like basically a wall, a mountain to climb.
Yeah.
Like even me and Juan, we've been doing physics for like 8 years, and that's also theory work as well, theory classes.
Theory classes.
And
yeah.
I still don't believe I can contribute meaningfully in a theoretical way to physics.
Yeah, the idea
It'd
is
be
that,
very hard.
Well, the idea is that you contribute meaningfully after you take on a whole project that spans maybe 4 years.
Yeah. And that's after you've already done all the preliminary work to understand physics at a basic level and catch up to where we actually are nowadays.
Yeah.
Like I still haven't really caught up even to where we are nowadays. I've caught up mostly, but in some sectors or some areas, like I don't know quantum field theory. Like I couldn't do field theoretical work, which is what the route people typically go when they're trying to find theories of everything of the universe. I don't know shit about that, so I could never contribute to that without a lot of studying. But I'm farther than a lot of people are, because I have a background in physics. But that just gives you a level of how difficult it is to try to contribute meaningfully in the physics theory realm. So with that said, experimental physics would seem the way to go. So I kind of tailored my this podcast to the experimental way.
Yeah. Well, I will say that there are numerous resources out there on, like you can teach yourself physics. There is some stuff out there, but
you could definitely teach yourself, but it's the time cost, right? It means you're going to have to spend years probably teaching yourself.
Look, the idea is that we spend our career as studying physics in a sort of linear trajectory, right? Every year you kind of take classes and, you take a certain amount and you kind of taper off at the end, right? Because you start, you gain more and more knowledge and it's a lot less of new foundation that you're building on.
Well,
there's
you're
a
building
a lot less new
foundation.
information that you're taking in towards the end, so it's not as world
shattering.
Yeah. So in the beginning, the slope is very steep.
Yeah.
So
you learn a lot of new shit at once.
In the first 2 years, maybe 2-3 years, and then after that, it gets a lot less like earth shattering, like we were saying. So there's a lot of courses out there, like MIT courseware. There's a good website if you just Google, I think, so you want to be a theory student.
Oh, I never saw that. Okay.
There's a professor who gives like basically a top 10 list of books or textbooks or reading, basically mandatory reading that you should know if you want to be a theory physicist.
Perfect.
Yeah.
Stack Exchanges is also a great website for me because like any question I want to know, I just type the question and I type Stack Exchange next, and there's usually a deep and meaningful answer attached to it. So like if you say like, what books should I get for learning physics, and then type Stack Exchange into Google, then you'll probably get a really nice answer from that.
Yeah, and you're gonna have to learn math.
No getting around it.
No getting around it.
Yeah.
As much as I hated it.
Even as an experimentalist, you're gonna have to know math.
Yeah.
So if anything, concentrate on calculus.
Yeah. And really, that's really the only thing you really know how to do.
So if you can do calculus, you actually are most the step of the way. Like calculus and differential equations is probably the most important.
Yeah.
And that's it.
And that's only because, F equals ma. Newton's
Yeah.
I guess.
Well, that's algebra.
Laws.
Well, I guess it's
No,
differential equations. You're right.
Yeah. Because like that's all you really need if you. The whole point of a physicist is to find the equations of motion.
Oscillators too, bro.
Huh?
So don't say that because harmonic oscillator too.
Oh, true.
You know.
But I'm saying like the whole point of being a physicist is finding the equations of motion in some sense. Like you're trying to describe your system, how it's going to behave,
right,
in some future time evolution.
Yes, and for the layman out there, equations of motion means that you should be able to quantify how a system moves in time. Mm-hmm. So what an equation of motion does, it says like the position in this system will be this at this point in time. Or you'll say the velocity of the system will be this at this point in time, or the acceleration will be this at this point in time. So when you get one equation of motion, you get them all basically, because they're related in calculus with derivatives and integrals of each other.
Yeah.
So then that's pretty much the end of that's the name of the game, basically.
That's why we say you need calculus. Yeah. Take Cal 1, Cal 2, Cal 3. Maybe take differential equations.
This is if you're doing classes. I'm trying to do this for people not taking classes.
No, I know, but I'm saying like you're still going to need that.
You can get around some of it, though.
If you want to make contributions.
You can apply 80-20 principle, I think, pretty heavily. Because our path was very much it's the typical path of you got to learn all this stuff, even though you're not going to use any of it.
The very technical.
Yeah, you could optimize a lot of this stuff.
You can.
If you follow Pareto principle and do 80-20, you can skip past a bunch of the bullshit. Like, honestly, I think...
At minimum, Cal 1, Cal 2, I think.
I would say just like no certain things.
Calculus, huh?
Like no certain things. Like on our website, Eigenbros.com, we have math problems. Mm-hmm. I have some math integral problems. Mm-hmm. And if you can solve all of those math integral problems, I think there's like 36 of them. There's also some other ones, like I have one from Black Pen, Red Pen, and also Flammable Maths. But if you could solve all those integrals, then you are sufficient enough to understand. You know calculus then, in my opinion. If you could solve all those, you know calculus at pretty much the highest levels you need. Mm-hmm.
Yeah.
I think you would have some trouble solving those ones.
I think a couple of them I would.
So if you can solve those, you're good. You can solve those, you're good.
I would say I could probably solve maybe 90% of those. But then I'm pretty sure you put a couple on there that are really tricky.
I didn't put them on. Somebody made the list. Yeah.
Oh, someone made the list.
Yeah.
Oh, okay.
Yeah. It's good. It's good practice for sure.
Okay.
Yeah, there's some tricks.
If you have to integrate by parts, I'm gonna be very upset.
Yeah, there's a lot of integrating by parts. There's some shit in there that you would forget. Like it's like integrating by parts. There's some absolute value stuff like piecewise.
Oh, okay.
There's yeah, it's tough.
See, but that's the thing. I've seen all this before, so I have some familiarity.
Yeah, that's why you don't once you've done it, you don't need it, right? Because you can just use Wolfram.
Yeah.
But I'm saying for people out there who are just starting, if you can do those by hand and just get it under your fingers, you're going to be pretty set to go in terms of calculus.
Yeah, true.
And of course, you can forget it later on in your career when it doesn't matter anymore.
Well, because at some point you transition to like an experimentalist. At least for me, there's no point in crunching numbers by hand. You you go more to computational resources to do that stuff for you.
Right, and actually, I guess you could even argue that then don't even bother with that. Right, if you can calculate it with a program, then you don't need to. Because we're trying to shorthand people to want to learn this stuff. We don't need to learn all these things. 80-20 principle applies.
Okay.
If you can look it up, if you can type it in Wolfram, do that instead.
Yeah, but a lot of papers and stuff are written in calculus.
Yeah, but if you have the equation, then you have the equation, right? If Wolfram can solve it, then why do you have to give a damn?
Yeah, but you need to know what it means. Like, if you see the integrand symbol, like, and you don't know what it means. Okay,
sure.
Like, you don't know what operations to do or really thinking about, like, what's going on there.
Yeah. If you can at least understand the important aspects, then you're good then, I guess.
Yeah.
But moving on, so I wanted to come up with, okay, what are the barriers to being an experimentalist? So, of course, the giant barrier to being an experimentalist is money, right? It's going to be impossible for you to try to replicate, $250,000 laboratory equipment that people have, in research labs. Like, one of my advisors had, like, a spectrum analyzer that was, like, $70,000 or something.
Yeah.
Some pieces of equipment are like $500,000, $1 million.
$1 million SEM.
Yeah,
Scanning
like
electron microscopes.
you'll never like unless you're rich, of course. By all means, spend your money on that stuff. But like if you're a normal human being, then odds are you're probably not going to be able to make a setup like that.
No.
So then you've got to find some cheap setups, or you've got to find external funding. So this is where I was thinking about, okay, so how would you actually get the means to fund your research? Mm-hmm. And actually, there's some interesting websites out there that are government funded, that governments have grants for individuals. I don't know if you knew this one. I didn't know this. You can actually get and apply for grants as an individual sometimes. So let's say you're like just a guy who has a particular solution to a problem that the government grants are looking for. So let's say you have some kind of
so they're almost able to contract you.
Yeah, they can contract you out basically as long as you write a good grant proposal and show that you can complete this, with some convincing evidence that you can do this.
Yeah.
You can work on certain projects funded by government grants. Like there's some websites called I think it's Grant Watch. And the other one I forget, maybe it's called like Grants for Individuals or something. And I saw like thousands of grants for individuals on there. And they're all looking for certain solutions to particular problems. Now, I will put the caveat on there that usually most of these grants are for if you're tied to an education institution or nonprofit. So, of course, it's better if you can be attached to one of those, but you can still get grants as an individual.
And I'm sure it also helps that you have some
background.
But
it's not saying you require it. I specifically looked for this saying like you don't need to have a physics background
like
to
a
do this.
Bachelor's or anything. Yeah.
Like you can do it as long as your grant writing proposals is convincing, right?
I don't know. I think it's rather dubious. So like I don't know if I imagine you do need a bachelor's in something, like some certification.
It didn't say it.
It didn't?
It didn't say it. I think if you can at least prove it somehow. I don't know how you prove it. One of the easiest ways to prove it, though, I would imagine, is to be involved with an actual organization. So let's say if you were having trouble, let's say you went through the grant process and were trying to apply as an individual, you can actually join up with nonprofits somehow as your profit sponsor. So let's say you have a local nonprofit who does science-related stuff. You could actually have them sponsor you for the grant. So you just join their organization so that you can get the grant through them. So now that you're affiliated with a reputable organization, then they'll be more likely to trust you with their money.
Right.
So there's ways to get around these things. And of course, if you're educated, then you're even more gold. Because like teachers always get grants. So if you're a teacher, if you're involved with any kind of government organization, then you're pretty much solid.
Nice.
But those are just some ways to skirt around the problems you might have as being an individual.
Yeah.
So they're kind of like chump change usually a little bit, but if you can get a few $1,000s here and there, I mean, that ain't going to hurt, right?
No, and I imagine if you're in industry too, you may be able to, like, if you're working for a nonprofit or something, you can probably wiggle your way into some money or finagle your way into a project. Like we have a friend who works for a battery company now, I guess. Yep. And maybe that, like, let's say you're trying to solve one of these battery tech problems that DOE always puts out. They always the DOE, Department of Energy in the U.S. Always gives grants out to solve certain issues. Like last time I saw one of them in particular was trying to achieve sort of similar efficiency with silicon chip systems. That quantum, like solving quantum problems using silicon or something. Okay. It's a weird grant proposal, but it was like a huge grant. We're talking hundreds of millions of dollars.
Oh, damn.
Yeah.
So you have to have a really good grant writing proposal for that.
Oh, yeah. But I mean, it's
the more money it requires, the more money it is, the more proof of concept you need to give people for them to shell out that kind of money for you. Yeah.
It has to be silicon based, like silicon based quantum computing of sorts. I don't know. It's weird. It was a weird proposition, but they're like, we want to see this. If you can show us a proof of concept, we'll give you some money.
I see.
So
interesting.
Yeah. Anyway, but there's a lot of that stuff out there like that. Yeah.
Okay. Cool. So I guess the other thing I was thinking was, okay, then what type of research can you do as an experimental physicist if you're on your own? And I was thinking one of the most feasible ones. So there's two I came up with. One being computational physics. So computational physics, because obviously computers you don't need a lot of money for computers. Of course, with computational physics, it's about the compute power, though, right? So when you start to have more cores, then the cost starts to add up, right? Because supercomputers are just like a room of shitloads of processors, right? That cost in the millions of dollars, so it can get really pricey. But with physics, you can still do simulations and things on the order of, like having a few, like maybe let's say like 10, 20 processors, and still get some good results, like simulations and things. Because, like high energy uses like GN4 to simulate particle collisions. And micromagnetics, that's some research I used to do back in the day.
Yeah.
They would solve the Landau-Lipschitz-Gilbert equation with programs like OOMF is one, OOMF. That's a common one to use. And there's other simulation software out there that you can use and run. You can run simulations on those, and you can even write papers on that if you can find something elucidating, And you can just simulate things all day at your own leisure and make up your own configurations of things sometimes. And that's a very doable thing, right? So computational physics seems very rife for non-physicists to do. Because you just need the money to shell out for the computers. Let's say if you want to make a cluster, computing clusters, combining a bunch of processors together. If you got the money, just buy like 10, 20 computers and make yourself a cluster. And then you can outsource even your stuff to physicists, even if you want to, for time to use on your PCs.
Or buy a bunch of used PS3s and put them in your garage. You could also do that.
Do those have good compute power?
Well, the cell processor makes them particularly useful to solve certain kinds of problems, I think. And I know a lot of researchers were buying them because of this. Because apparently Sony put a lot of money into the cell processor and didn't really milk everything they needed or they wanted to get out of it.
I see. So the researchers were like, we're going to capitalize on this.
Oh, yeah.
Okay.
So
there you go.
Yeah, and I think you can still farm a bunch of PS3s and use them. So, I mean, by all means, like you use stuff like that. You can buy used consoles and stuff instead of them being in a landfill.
There you go.
Maybe you could even use
get them cheap.
Yeah, and maybe mine crypto with them too. I don't know.
That's another topic. But yeah, so computational physics is definitely one that is doable. And there's even open data sets online. So like CERN has access to open data sets for their particle collisions that you can run data analysis on.
I didn't know that.
These are not open with the latest research, of course.
Yeah.
They're like, I think it goes up to 2012.
Because they still got to cook up the numbers. So
exactly. So you're not going to be able to do...
I'm saying like fake them so that...
so they can pretend that the God particle exists.
Yeah.
The Higgs boson.
Exactly.
But no, you can at least use those data sets as practice. And then if you want to just, test your systems and make sure you can actually start analyzing data, maybe you could even contact one of them and say like, oh, I can help you process data or something.
Yeah.
I think it could be feasible for physicists to let you help out with them once you have the knowledge and the equipment to be able to do something like that, right? Like physicists use technicians and outside contractors a lot of times just to help them with stuff. Like we have lab techs and things in existence.
Yep.
So, I mean, it's not unheard of that you could have collaborations with physicists as a non-physicist if you have useful equipment and resources.
Skills,
and skills. So that's one major area that I think would be very good, a good contributing thing.
Because I have friends who are adjacent to physics, like physicists, like as I guess scientists, as a more broad term, but like they work at it's not a I would say a national laboratory, but it's a laboratory that is contracted out some work from NASA, I believe.
Okay.
And he's not trained as a physicist at all, but he helps a lot of physicists to do the kind of work that they do. So
there you go.
He's a lab tech guy. He knows he often knows what I'm talking about. I know a lot less than him about electronic stuff because he's trained as one, but he's able to help like on certain things. We kind of meet in the middle sometimes.
Yeah. There you go.
So yeah.
Yeah, so don't be discouraged by that stuff. You can definitely do it. So yeah, and then the next other area I thought of for non-physicists to do or to be able to contribute meaningfully is amateur astronomy. So with amateur astronomy, there have been people who still to this day are finding like supernova explosions and rare events that astronomers miss because, there's so much sky, you can only point your telescopes in certain regions. So if you're an amateur astronomer, you can realistically find and discover events and things happening that researchers will completely miss, right? I mean, astronomy has a lot of room open for non-physicists as long as you have the equipment. So, of course, the telescope is a price to shell out, depending on how good of a telescope you get. But, guys and gals have discovered events with the naked eye. Well, not with the naked eye, but just with basic optical telescopes. So, I mean, these things are possible.
Get yourself a nice Dobson type telescope. You can also build
your
own. Yeah, but you can also build your own. Like, I think
make your own observatory.
I mean, like, look up YouTube videos. They have this. Like, people make their own type of telescopes. Like, because there's a lot of DIY astronomers, right? There's a lot of amateur astronomers that are out there doing their thing, and they contribute. You can contribute meaningfully to that field pretty easily, I think, than any other physics field.
Yeah, that's probably one of the lowest barriers to entry things.
Yeah.
I mean, of course, the telescope's a lot, so it could be pricey, but it's very understandable and very doable. Like, anybody who doesn't even know anything about physics knows how to look through a telescope.
Right.
And they can catalog.
Yeah, and I mean, really, all you need to really is like to save up maybe $400
for a decent telescope.
Telescope, yeah.
Yeah, of course, you're probably not going to be doing leading edge stuff with a $400 telescope, but the thing is, it's actually possible. Though.
Yeah,
it's actually possible.
It is. You get filters and magnifiers. It's an expensive hobby, but I mean, like we were saying, if you want to contribute to that, I think that's probably the easiest one.
Yeah. And like Juan was actually saying too, with the filters and things, you can start getting. You can filter for infrared stuff. You can look at UV light. You can do a lot of stuff with that in optics.
Yeah.
It's a very interesting thing to do, and it's a very open field, and you can explore a lot of shit with that. Honestly, so amateur astronomy and computational physics were the two big ones I came up with.
Lowest barrier to entry. Yeah.
At least that I could think of. Is there any other ones that you could think of? One.
Well, Mickey Okaku would say nuclear physics.
Nuclear physics.
Didn't he build a particle accelerator in his backyard?
And that's high energy physics, but I guess not high energy because he literally was using it with his basement electricity or something.
Yeah.
But that was probably like a goofy, like
he used a
wide-eyed, bushy-tailed kid project.
Yeah.
Because there's like how are you gonna achieve any kind of useful energies with a particle collider in your fucking garage?
Yeah.
I mean, come on.
I mean, there's a lot of. I mean, you can do experimental stuff like that though. Like you can.
But those are all not. Those are not able to contribute to the body of knowledge.
Yeah.
Like, there's a bunch of stuff I can think of that are like you can do and kind of like reinvent the wheel. But I'm trying to find things that specifically people can do that are like you can be on the leading edge, and you don't have to be trained as a physicist.
It's hard to do that with. I think condensed matter physics, because you need such expensive equipment to probe. You need to go to really low temperatures sometimes to see some phenomena like superconductivity. You need really low temperatures, and then
and also exotic materials sometimes that you can't fabricate without a crazy lab.
Because you need to grow crystals. You need a furnace that does it.
Yep.
You need certain like chemicals that.
But what I was saying with that. But computational physics can actually apply to all those fields because for the example I gave with oomph and simulation stuff, I used to simulate nanomagnetic triangles when I was doing research where it would simulate magnetic domains in those things to find if you can create a 3-bit logic gate, basically.
I see. Okay.
Or like a 3-bit logic unit or something. So you can still do simulations in condensed matter physics as long as you know what you're looking for and you know how to use it. So even in condensed matter is possible, but it's going to be like simulation computational software based stuff. Right.
Yeah, I guess
odds are you're probably not going to be able to afford the equipment.
Yeah, for experimental stuff. Yeah. So I don't know. That's kind of hard. I would say maybe another field that you could contribute to is maybe optics. You could probably do optical stuff.
Yeah. I was thinking that, but I was trying to think of what are some leading edge optics stuff you can actually do that are reasonably cost effective. Because that's still getting into, because some of the optics, the real optic equipments, start to get really pricey.
Mm-hmm.
And the other part about optics tables is you start to get an accumulation of a shitload of optics,
Mm-hmm.
right? Because you need one thing to do the next thing to do the next thing.
Yep.
And then you wind up spending, several hundred thousands of dollars on optics equipment. So you feel like it won't get out of hand, but then after a while, you're like, oh, I need all these optics to be able to do this one thing, right?
Yeah. Yeah, maybe not. That might be a little too complicated.
Because I think even when I built a laser frequency tripler with I think 4 optics, the 4 optic crystals, it got into the tens of $1,000s range.
Wow.
That was only 4 pieces of optic equipment.
Yeah.
Right.
Huh.
You're just like, oh, it's just 3 little. You're like, oh, it's just 3 pieces of glass or something.
Yeah.
But no, it's like these very highly manufactured pieces of glasses with certain properties.
Yeah.
And they wind up being super expensive. So yeah, I'm not sure optics would be good. Maybe there's some clever things you can do with optics. I just don't know.
Yeah, I'm not sure.
Yeah.
I'm not an optical technician guy either. So.
But of course, any condensed matter physicist, we all deal with optics at some level.
I mean, I guess if you wanted to, let's say there's certain low barriers to certain projects. For instance, if you wanted to make a better optical fiber kind of material. Let's just say you were building in your backyard. You found a material that you think is a better material than what we use now. I think it's high purity silicon glass.
Yeah, I think you're getting. I think it's going to be very tough.
Yeah, I know. But that's what I don't know. Just like a lower loss rate or something.
Yeah,
in
but
theory,
then you have to know how to test that as well.
Yeah,
right?
Yeah.
And to actually know the material in an educated way to guess.
Yeah.
To find it. It's getting tough.
It is
a
lot
to
harder,
make optical fiber is not easy.
Yeah, I
right?
know. It's a lot more difficult than it seems. I think for condensed matter, there's a lot higher of a barrier of entry to experimental stuff. But the theory stuff is, like you're saying, very approachable. If you download a lot of models, you can even do calculation. I mean, you need to know theory, but
it's approachable in the sense that you don't need money. The problem with theory is time.
Yeah.
Mostly time,
knowledge,
right?
Time and knowledge, yeah.
Yeah, it's the time to accumulate all that knowledge. It's like to get to the level of leading edge is going to take you a lot of time.
Yeah.
And I know a lot of people are not patient enough to do that.
No.
Well, they just don't have the time, right?
Yeah.
That's why I think you get people trying to do theories of everything and stuff without doing much research because they just don't have the time to sink in just to learn the bare to get to the modern age of physics, right? They want a quick solution to disproving Einstein.
Yeah, so many of these guys dream about being on a beach doing theoretical physics. I'm like, that's not going to happen.
It's a great dream, though. I'm saying more props to them if they can, but man, you need to do a lot of preliminary research and study to get to the level of a modern day theorist, theoretical physicist.
Yeah, I don't think you hit your stride in theory. I think
until like third year graduate,
30,
maybe.
Yeah, I think. I think you're post if you're in academia, but you're probably post grad or something.
Oh, postdoc as well, you think?
Yeah.
No, because they can at least start doing theory because this one of the ways theorists can actually save themselves and get some real applicable skills is by doing computational stuff.
Yeah.
So theorists become programmers at some level too, typically in physics, and they'll do simulation software, and they'll start to simulate theories and whatnot. So. But, of course, that still requires all the preliminary knowledge beforehand. So you can't really just skip to that, I don't think. Maybe you could, but you're not going to understand enough to be able to make educated guesses on where to go next. So, yeah.
Well, those are the only 2 options. No, I'm just kidding. You can also try disproving certain conspiracy theories, like flat Earth theory.
I don't think that's what physicists do.
No. But, you could spend time doing stuff like that.
Yeah, you could, I guess. I mean, of course, if you contribute in any way, like let's say if you just had like an Instagram page and just wanted to solve physics problems and share it with the world, like that's
You're
great.
Contributing in physics education, yeah.
Like I feel very, very fulfilled meaningfully just by contributing, with the podcast and just like the Twitter stuff I'll post. Like it feels useful, like in some sense it feels like you are adding to the body of knowledge. So at the end of the day, if you guys really are like physics, then make your own contributions even with the easy stuff. Go to classical mechanics or beginner introduction physics. Make a post about some cool thing you found out about light waves or something. Like that stuff's always going to be timeless knowledge. Like just because it's been done doesn't mean it's not useful.
Yeah.
And you may have a new perception or take on something that someone else did not have.
Yeah.
You know, I think the more takes and the more visuals and the more explanations out there are on some concept, like that's always better in my opinion. Because like I've seen some explanations that people might think is the well-regarded explanation, and I completely just don't understand what it's saying. And then sometimes if that's the only thing that's out there, it's just like, well, I'm fucked. I guess I have to create this. I have to create an explanation on my own now of the way that I see it.
Yeah.
And then I'm like, why doesn't people just do this? Like my way I just came up with is so much better than this way here.
Yeah,
because there's different styles thinking.
Yeah, and physics needs a lot of different perspectives of that, because I think you and I run into this issue quite a bit.
So often. So often I will think like we have so much better explanations than whatever the literature
Wikipedia
is out there.
Or like even the Physics Stack Exchange. The Physics Stack Exchange is notorious.
They're good though a lot of times, but they also can go a little bit ham in terms of it depends on the person answering, right?
Yeah, it's a lot of how would you say intellectual certain kind of size measuring. You know what I'm saying?
It depends, because some people do that, but then others don't. I get a lot of fruitful answers on Stack Exchange.
That's good.
But then, of course, it's usually like there will be one just like overly just like, bro.
Yeah.
Do you really need to be
that?
Yeah. Do you really need to be going this crazy on the explanation? Like,
so we do need a lot of contributors to physics education, I think.
Yeah.
It's important.
Yeah. Physics education, honestly, like you can endlessly contribute to that and it will be meaningful. Like you have like, there is so much room to explain so many concepts better. Like it's actually unfathomable how much is not really explained just in a different perspective. Like different perspectives are so useful.
That's partly why Feynman also is famous too.
Yeah. Because he had different takes on things, right?
Yeah.
A lot of people will just regurgitate the same takes, right? If you have new takes, it's refreshing because it's a new set of eyes and a new way to look at things, right?
Landau as well. He also had some new takes and interesting like readings into things. Yeah.
So if you enjoyed just learning physics at the bottom up, maybe that's how you want to start your journey.
Yeah.
If you want to just start learning physics that way, start trying to explain things in a new way.
Yeah.
It's very possible.
Yeah.
Did you have anything you wanted to add here, Juan, about potential things that you can do to contribute to physics as a non-physicist?
I don't know. I think we kind of covered most of the things. I mean, they were surprising to hear that. Yeah, I guess that computational and like astronomy is probably the only two that you can really contribute. I was thinking
at least that I could think of.
I was thinking maybe acoustic physics, but then I'm like, that's kind of more of a application
niche too.
And it's kind of niche or whatever.
Yeah.
So I mean, can't really think of much else. I mean, you could try solving like these cute little problems that are out there.
What, millennial problems?
Yeah. Cute. I call them cute little problems, but I mean, they're big problems, but you go at it if you want. Like, try it out.
It's the worst. It's the worst advice ever. Well, I was like, yeah, you're a non-physicist. Yeah, go out and solve the hardest problems in existence.
You know why? But you know why? But if you're motivated to solve that one question, you have to learn so much to solve that question.
That's true.
Do you see what I'm saying?
Yeah, I guess so. Take 40 years to learn solve one problem.
If you're that action oriented, then I would say go to the millennial problems, pick one.
Yeah.
And then you will realize how much you have to learn to answer this question.
True. Yeah. Actually, that's a great point, Juan, because I think a lot of times when you're trying to learn something, if you just want to learn or solve something, start with the problem and just work from there. And just work backwards. Whatever you don't understand, look into that. Yeah. Then go back to through there. You go to the next rabbit trail. What's that? What's that?
Yeah.
And eventually you build a chain to what you're trying to learn, and you could just become an expert in that one area there, which is
ultimately that's what happens.
Yeah, that's ultimately what happens anyway, right? That's what PhD literally is. It's like you're becoming an expert in some really niche area or one specific area. This is it. Of course, we get the luxury of having a generalized knowledge because you're in a school setting where you can kind of accelerate this learning process.
Yeah.
But yeah, if you just start with a problem that you want to solve, honestly, I think that's one of the greatest ways to solve things. You just start with one problem and just build from there, and just keep spinning your wheels in that one thing, and just trying many different approaches on it. Reading all the literature on how other people tried to solve it. Reading other things on how you believe it might be solved. You know, you can do that for a lot of things, and that's how you actually really solve problems. That's actually what you're trying to do at the end of the day anyway.
Yeah.
So,
yeah.
Yeah.
I was thinking another thing you could do, say if you wanted to contribute as a non-physics person, is if you know this stuff to some degree, you might be able to tutor to help you get better at it.
That's a good one.
Yeah.
To give back to the community,
well, that, and also to help you refine your skills a little more. Like if you, I don't know if they require credentials in tutoring services, but
it depends.
It depends.
For mine, I tutor with a service that does not require credentials, but they require you to take an exam
I see.
to prove that you at least have competency in the area.
Yeah.
But it's very easy, and you can even look up the answers. Like, there were some things I looked up, and I was just like, I don't know what this is. But of course, I'm competent, so I didn't feel wrong looking it up. But yeah, I think you're right. With tutoring, which is what I do now actually as well, you do really refine your understanding of things.
Yeah.
And you really, honestly, I don't think you really truly understand anything if you can't explain it to someone else. You should be able to explain whatever you're doing to someone else.
Yeah.
Anyone.
Yeah.
Like even a little child, I think you should be able to explain it to, right?
Yeah.
Because you should be able to really dumb down or enhance your knowledge depending on whoever you're talking to, and that means you have a full competency of the subject.
Yeah, you've thought about it enough where you can sublimate this point to something really digestible, or like really expand on it and have a whole fucking discussion on this one particular thing. Yeah.
Right. There's actually a YouTube channel, I think, called like Explain in 5 Levels or something. Have you seen it?
Yeah, I've seen physicists go on there, like Sean Carroll and some other guys.
It's a good concept because it's like that's literally the process of how you have to understand how to teach something.
Yeah.
You have to explain it to someone who's no competency or no understanding or familiarity, which would be the child. And then let's say the expert, someone who's an equal in your field. You have to be able to explain it to them as well. So that's how you truly understand or gauge your competency in a subject, is if you can explain it at all of those levels, then I think you truly understand what you're talking about.
Yeah, and not everybody's. That's a skill. Not everybody's good at that either.
And a lot of people are not good at it. Like people automatically think that physicists are these super geniuses that know everything, but I've noticed that maybe I might even dare say most physicists are not very good at explaining things because they actually don't understand it that well. They understand things because there's a thing
very
that you
subjective way, I think.
Well, there's a thing you can get in physics, right? You can you can understand a concept and how to do it, but then there's a whole nother level to reach where you can understand it well enough to explain it to someone else.
Yeah.
And I think a lot of people don't get there because they already understand it and then they're good and they're out on to the next thing.
So what I mean, like the understanding is very subjective. I think when you have to say it to somebody, you have to more take a framework where now you have to think about making it relatable to a wider audience in some way.
I see, because you have to step outside of yourself and now see like how do other perspectives understand this problem?
Yeah.
That's true.
You know what I mean?
Yeah.
Because like I find myself doing that sometimes where I will go into something and then I'll take some level of, I'm like, okay, this kind of makes sense to me.
Yeah.
And then I say it to somebody and then they're like, what are you talking about?
Yeah.
I'm just like, okay, let me think about this. And then I have to kind of say it in a way that's more refined or something.
Right.
Yeah. But yeah, tutoring will help that a lot.
For sure. You'll feel really dumb though for a long time. Like any skill though.
But yeah, you can contribute in that way. I think it'll
because it really exposes you for the shit you don't know as well.
Yeah.
So when you really don't know something basic, you feel like a fucking idiot. And you're like, God damn it, I really should know this, but you just got to take the lumps. You know, just be dumb. One of my quotes I love to say is, "Be dumb now so you can be smart later."
Yeah.
Don't try to be smart now because people are going to know you're dumb. Okay, so just be dumb now, be smart later.
That's why I never pretend to be smart.
Yeah.
I'm like, I don't even tell people.
It's not worth it.
I don't even tell people I do physics because then they have some presumption of like intellect.
Right.
And I'm like,
yeah.
No.
It's best to just save the embarrassment and just admit you're dumb because we're all dumb.
Yeah. We all have limited knowledge, and Yeah, I think. What was I gonna say? I forgot. But anyway, yeah.
Yeah.
Those are my 2 cents.
Cool. I like those though. That's good.
Mm-hmm.
So I guess the short summary of this is, if you want to contribute meaningfully, I would go for experimental physics.
Mm-hmm.
Also, if you have money, that's going to help you out a lot too. So you can get the gear and the equipment, and then grant writing. If you can learn the skill of grant writing, that's very critical. I think that's a great skill to have actually.
Yeah.
Because if you can write grants, I mean, you can apply for a lot of shit. And the thing is, once I think you start to get grants, then you continuously can get grants because you already know what it takes to actually successfully earn a grant.
Yeah.
So grant writing, I mean, that's useful across so many disciplines too. Like not even physics. Let's say if you want to just go in like, politics or education or anything, like grants are critical.
Yeah, and like even if you just want to contribute, right? These are ways to contribute. You can you can go work as a lab tech, and if it's a lab that's physics adjacent. For instance, like I had a philosophy student that worked in my undergrad. He worked in the same lab that I did, and he didn't even know physics. So he was just kind of like, I'm here because I enjoy it and I want to be around physicists and gain their perspective and talk to them and stuff. And I mean, that's what he got out of it. In some ways, he might have been contributing to like a discussion and dialogue and stuff. But in some ways, if you want to get more out of like just be around physicists or those kind of people, then by all means, like put yourself in. Those are ways to put yourself in those environments.
Right.
Yeah. So
beautiful. What time are we at? Damn, we're a short podcast.
Yeah, this might be a short one, but I think that kind of like synthesizes it. Yeah. I mean, I guess if you have any, I was going to say, yeah. Also, if you're going to talk to physicists, don't. You're going to get a good range of people, walks of life.
Yeah.
And there's a certain way to talk to them sometimes. Like
in what sense?
Because like I was saying, like some people have very subjective frameworks for their body of knowledge.
Right.
And some people will take offense to it depending on where the maturity level is.
Yeah. Physicists can be very emotionally sensitive.
And immature too.
Yes.
And not in the sense that, I'm talking about like comedic sense. I mean it like
emotionally immature.
Yeah. They have.
It's definitely a very common thing.
It is. I think because a lot of them poo-poo feelings, and it's like they never really understand.
So it's like they just get out of control with their own feelings. Yeah.
So, and I've dealt with people like that in the lab, so I know I understand people that.
Yeah, 100%.
Be aware of that. Be aware that there are not a lot of. Most of them don't fit into the trope of a physicist being very robotic and emotionless. In fact, I think they're probably very emotional. They're also very emotional people, but like human beings in general. But don't assume that they're robotic and blah blah blah. Like they're.
But also don't try to label all physicists as closed-minded. Like people will, when I will dismiss someone's theory or something, and will say it's wrong or like not be interested in it. Yeah. I've had people try to characterize me as some closed-minded scientist who only likes empirical things. I'm like, bro, if you really actually understood any of what I'm saying here, like I'm probably one of the most open-minded people I can possibly have. Of course, everybody would say that. Their thing, but like truly, I am extremely open-minded. I think the thing is, I just am very not susceptible to bullshit or wrong things. Yeah. So if your shit is wrong or bullshit, I can immediately spot it like as soon as I see it. It's a very rare day where anything's going to be able to bullshit me. So it's like that's the thing. It's a lot of times you may think these theories that you have or whatever are that they're just. Government suppressing your knowledge, or physicists just don't take you seriously because they just don't get it. But it's like, I'm sorry, guys. We've been wrong so much that it's very hard. It's very hard for us to not see through something that's really bad or really wrong.
Yeah, and a good physicist will break. I mean, depending on the level of patience that the physicist
sometimes
has.
You just don't even. It's not even like you don't even want to entertain the idea. Like, for me, I just don't even want to entertain the idea of sometimes when I see something that's clearly so bad or so wrong. It's just like
for me, I'll tell them like where they're. A lot of the time, I'll just say one thing. Yeah. That I think is like I already see the crack. and that's the crack. And I'll
well,
point
Juan's
it to
also the nice one. So.
I am also more patient with people.
So maybe give it to Juan.
I'm very patient. Yeah.
I get very annoyed by
I know you do. I know you're just like, whatever.
I'm just because I'm so over it. The thing is, as a physicist, I'm so used to being wrong all the time.
Yeah.
I am wrong all the time. Part of being a physicist is you're supposed to be wrong constantly.
Yeah.
You're only right like 1% of the time. You find some new theory, you find something that you're right about. But then when you're right, you're fully fucking aware that it's right.
It's great.
Because you've attacked it from so many angles in so many different ways. You're convinced fully that it's right.
Yeah, like now I'm...
Until sometimes it's wrong. But
yeah, like now I feel like a Lagrange master.
Yeah.
I feel like you could throw any Lagrange at me and I can pretty much get it down. So
majority of time with physicists is if you're a person who likes being right all the time, physics is not for you. Like if you're a person who likes being wrong or doesn't mind being wrong all the time, that's really what a physicist is. Like I'm constantly wrong. So for me to see something, I can spot when it's really wrong because I probably already tried that, or or I can see that rabbit trail that looks familiar to maybe with something that I've seen before, or I just know the correct path that usually you need to go. Yeah. So it's like physicists have just been through too much wrong shit.
Yeah. Well, but yeah, I mean that's pretty much it. I think if you guys have any comments, please leave them in the in the chat
I guess
below.
we should leave a question though.
Yeah, we should, but I couldn't think of one.
Yes, I would say if you are so my question is, I guess, so if you are a layman or a person who's a non-physicist, what thing most interests you to learn? And then I guess a question for the actual physicists and people who are scientists, do you guys have any other things that and maybe not even physics, maybe just science in general, like if you're a geoscientist or something, for example, like what would you say are some areas in your field that a non-scientist person in that area would contribute to as well?
Yeah.
So those are my two questions.
Yeah, it's a good question.
All right, and I guess we'll close it out.
Yeah, that's it. If you like what you heard, please like, comment, like we said, and then share and subscribe.
Yes.
And follow us on all our socials.
Yes, so eigenbros.com is a website. Follow us at Eigenbros on Twitter, Eigenbros on Instagram, and then Eigenbros2 on TikTok. And, of course, guys, once again, if you like our content or have gotten any value from us, be sure to think about contributing $1 to our Patreon.
Yep.
Very easy to find. Just type in Eigenbros on Patreon.
Yeah. Like I said, more fast and loose, a lot more personal on those. But yeah. It's fun.
Yeah.
We have a lot of fun on
Not
those.
as much guaranteed to be physics, but if you just want to know more about us, you guys get a extra 30-minute podcast at least every week with that one.
Oh, we go over sometimes.
Yeah.
But we have fun, so it's good. Anyway,
there it is.
We will talk to you guys later.
Signing off.
See ya.